Okay, so in our first video looking at Kuryr, we had a look at how it creates load balancers using the OVN provider and the M4 provider. And we briefly looked at how it utilizes trunk ports within the VMs that are created, so the masters and the worker nodes, how they use trunk ports. So what I wanted to do in this video is just take a closer look at that to understand how those trunk ports are actually used and how we create VLANs on top of those trunk ports as subports, and they're attached into the pods using network namespaces in Linux, and that allows the pods to communicate directly with the network. So if we take a look at the documentation, we can see here that by default, when you deploy Kuryr Kubernetes, even if it's on Kubernetes and outside of OpenShift, the default is going to use this nested VLAN mode. And what that means is exactly what I'm describing, where we use a trunk port, we create that trunk port on the VMs that are created, and then on top of that we have subports. And in the documentation, there's even a section on how you might do that manually if you wanted to look at it and explore that as an option, just to get your head around how that actually works. So you can see here that we create a port, and then we designate that port as a trunk, then we attach that port to a server that we create, and then we set subports on that trunk. And then within the VM, we can configure network namespaces that are configured with that VLAN, or just configure interfaces using that VLAN, and that traffic will be allowed to pass through the trunk. So you can think of it the same way you would think of a trunk port on like a Cisco switch, for example, where you set up the port as a trunk, then you tell it which VLANs are allowed on that trunk, and you physically plug it into a server, and now you've got a trunk port that can support VLANs. So we will go back to the terminal here. And what we want to do is just have a look at the trunk ports that have been created. So we go network trunk list. So we can see there that we have one trunk for each of the nodes that I have in the environment. Let's see, get nodes. So there we go. We have 6 nodes. We have 6 trunks. That makes sense. So let's pick on a specific pod and we'll dig into how that pod's networking works. So the one we picked on last time was the OpenShift monitoring Grafana one. So we're going to do the same again here. So we'll just do an O wide and we'll see which node that's on. So Grafana, we can see that it's on worker 0 BVPHK. So that's the worker node we want to pick on. So let's do OpenStack-network trunk list again to bring that list back. So BVPHK. So this is it here. So we've got a parent port. So what we can do is do an OpenStack port show on the parent port. So on this parent port, we just scroll up a little bit, we can see here we've got the trunk details and it has some subports. So these are all the ports that are connected to that trunk and connected to this node. So that Grafana pod that we have, it's going to be utilizing one of these VLANs, and we'll have a look at how to figure out which one that is. But while we're in here, we can see some other things. The IP address, 10.0.2.82. What we want to do is just demonstrate that this is actually the port that's attached to the VM. So we'll just take that IP address. We'll do OpenStack server list. And we're just going to grep for that IP. I just want to demonstrate just to show that that is the actual port that's attached to the VM itself. So we can see there that that is the primary IP address of that node. So this is all good and well. We understand how that works, but how do we know which of these VLANs is being utilized by that Grafana pod? So what we've got is a custom resource definition called Kuryr port. So we do OC get Kuryr port in the OpenShift monitoring namespace. We can see that we have some Kuryr ports defined here, and one of them is the Grafana one. So we'll take the Grafana one, we'll do OC get KP. We can shorten Kuryr port to KP, -o YAML, because we want to see it in YAML output. We'll paste in that name, and it's in the OpenShift monitoring namespace. And we'll just pipe that to VI so that we can read through it a little easier. Okay, so here we go. We got the Kuryr port. We can see that it has some labels. It's got a finalizer there. scroll down a little bit, we can see the pod node name. So this is our worker node name that we saw before. And then if we have a look in the status, this is where all the information is going to come from. So we can see there's a MAC address, so that's handy for finding it within the network namespace on the node. We can see its IP address, so the CIDR it's in and the IP address of the pod itself. That's also handy information. And if we scroll right to the very bottom, we've got this VLAN ID. So we're using VLAN 949 for our Grafana pod. So if we do that OpenStack, so we do the OpenStack port show again. And we look for that VLAN, we can see that there it is right there. So we have a VLAN, and now we have the port that's associated with that pod. So now we're getting closer to being able to troubleshoot this problem. We could take that port ID, figure out how it's configured. We could then look for where it's defined in OVN. There's a lot of things we can do now that we understand which port that pod is trying to use. We can do a port show on it, for example. So again, MAC address, IP address, the VLAN tags. This is all like handy information to know because we're getting closer to understanding how that networking is actually connected. We can see it's configured as a trunk subport. So let's log into the OpenShift node. So to do that, we use ocdebug, chroot to the host. Then we do ipnetns. We can see that we have some network namespaces here. So if we just loop through that, we want to find that IP address. So we're just going to do a for namespace in the output of that command, but I'm just getting this first section without the ID stuff at the end. Then we're going to echo which one we're checking, and we're going to look for the IP address in that namespace. So there it is. We can see that it's in this network namespace here. So we do ipnetns exec into that namespace, and then IPA, and there it is. We can see that it's configured there. So from here, you could do a little bit more troubleshooting. If you're having issues, you could maybe start a new container or use the toolbox container. So toolbox, that will give you access to some binaries that aren't installed on Red Hat CoreOS or Fedora CoreOS if you're using OKD. For example, tcpdump. So now we can tcpdump and we can look for traffic going specifically to that pod. It would take a little bit more effort if you wanted to bind mount those namespaces in and do some work within the namespaces. I can look into that. We might make a different video on specifically troubleshooting because that's a little bit more effort. But just know for now that what we want to do is identify the port, the IP address for the subport, which node we're connected to. We can log in and we could use that IP address. So if we look for traffic going to that IP, for example, so this IP address, we'll go back into Toolbox. So what we could do here is IPA, so we want to TCP dump on ENS3. You always want to select an interface because you don't want to TCP dump on any. And then we're going to look for traffic going to that IP address. And straight away we can see that there's traffic there. So that's a good way that we can troubleshoot and make sure traffic is actually getting to our pod and coming from our pod. So that's how we can look at the trunk ports from the Neutron side, figure out which node it's connected to. Remember, it's always the trunk parent port that's actually connected to the VM itself. And that's just like if you configured it on a switch where you configure the trunk port and then we put VLANs over the top of it. Then we can log into the node. We can identify the namespace that our pod's in using the IP address of the pod. So that's the same as if we just do OC get PO O wide on the OpenShift monitoring namespace, Grafana. So there it is there. We can see the IP address exists here. So we know the IP, we can look for that in the network namespace, and then we can use something like the toolbox container to TCP dump and capture traffic going to that pod and making sure that traffic is also returning from that pod. So that's quite helpful. So the other thing we can do from the port perspective, we do that port show again. If we're still having issues and we can't see that traffic, Then we can look at the security groups that are applied. So this is the security group that's applied to the subport. So we can do an OpenStack security group show on that one and just see what rules are applied to that security group. So we can see there that there's a couple of egress and ingress rules that have been created by default. So that's one good thing that we can check next if we were still having issues. And the other thing we can do is we can look at the parent port itself because it also has security groups. It also has these allowed address pairs, which I didn't mention earlier, but these are our VIPs for our API and our ingress ports. And they all need this allowed address pairs so that keep-alive-d is able to float those IP addresses around between the VMs without them being blocked from the Neutron side. So we can see that this is our trunk port, and we can tell because it will say trunk here somewhere. Yep, so trunk details. We can see that there is a security group that is applied to this. Here it is here. So we can check the security group on the trunk port itself as well. So we can see there's quite a lot more rules here. So it's probably best to start from the sub port itself. Check to make sure your security groups are in line. Make sure that that traffic should be able to get through. Then if you needed to come here, there's obviously a bit more information that needs to be dug through here, but this is just going to correspond to the sub ports that are created. It's not quite as overwhelming as it might look. You just need to identify which sub port you want to be looking at and then take a look at it from there. Okay, so that's how you can collect all the information that you would need to begin troubleshooting. And I'm not going to go too deep into troubleshooting in this video because it will end up being really long. We'll make a specific video about troubleshooting. But this is how you can gather the information you need.